All right, welcome boys. This is chapter 14.1, scatter plot and association. Now basically plots are an association between two variables. Here you have an example, distance versus time. Normally in the previous chapters we had plots. The points were in a straight line and we joined them together. And then in some cases it passed through the origin. This is actually a linear proportional relationship plot. Now there are cases where points would be scattered around. Okay, points are scattered around, and you still will have to find a relationship between, let us say this was time and this was distance, or this was distance, this is time. Now in certain cases the relationship will be linear proportional, a relationship where the plot points will be on the straight line. In certain other cases, it may be such that the plot will look like this. Okay, distance, let's say x-axis is distance and y-axis is time. So how would you draw a plot, or how would you draw a line so as to find a relationship between distance and time? This is the question here. So what you should do is, if you have a plot like this is called a scatter plot. If you have a plot like this, the points are at different areas in the plot, and there is no relationship where a single line can capture all the points. So you need to plot it such that you have equal number of, if you're missing any points, it should be such that there are equal number of points on both sides. So if I draw a line like this, above the line there's 1, 2, 3, below the line there's 1, 2, 3, 4. So this wouldn't work, this line wouldn't work, because there should be 4 and 4, both top and bottom. So if I do this, you have 1, 2, 3 and 1, 2, 3. Okay, if I do this line, you have 3 points on the top of the line and 3 points on the bottom of the line. So this would be the solution. In the case of this scatter plot, this will be the solution for the scatter plot. Okay, in this chapter we are trying to learn, or they are trying to teach us how the solution is done. So do this example, activity 1. And another principle that we need to learn is the difference between clusters and outliners. In certain plots you see that points cluster together, okay, and there'll be 1 or 2 points here and there like that. Now this is not a linear relationship, but let's say it's a relationship between x and y. You have one scatter here. This is a group of scattered lines, scattered points, and you have the second scatter here. Okay, these are called clusters. Okay. On the other hand, these 2 points, they do not fall in any of these clusters. They are called outliners. Generally, when you consider this plot, or when you consider a relationship between x and y, what you do is you negate. You don't consider the outliners, you only consider the clusters. Okay, so this is the example of a cluster plot. Okay. And points, let us say points are all here and there. How would you find a relationship between distance and time? In that case, what you should do is you should find points in such a way that if there are equal number of points above the line and below the line, and then that line would represent the relationship between distance and time. Now, if the cluster plot is like this, where a cluster of lines, a cluster of points are on one side, and after some time on the x-axis, a cluster of other points are here. In these cases, you consider the cluster together. The outliners, the points that are lying outside the clusters, are basically called outliners, and you don't consider the outliners. Okay, that is the basic principle. Here you see an example. Okay, there are two clusters. This is one cluster. This is another cluster. But this point is an outliner. Okay, this is an outliner. But this is one cluster. This is the second cluster. So here, the relationship is between the intervals of time between which the eruption of the Old Faithful, this is a geyser in the Yellowstone National Park, and the plot gives a representation of the intervals between two eruptions. Okay, if the interruption, let's say the first interruption was here, and the second interruption was 40 minutes later, that's what this point represents. The next, let us say, is 80 minutes later, let us say, and that is what this cluster would represent. Okay, 80 minutes later. So this is the interval between eruptions. So you have one cluster here, you have another cluster here. What does this represent? You see here that if the interval between two eruptions is smaller, between 60 and 80, then the duration is only 2 to 3 minutes, which is the eruption only happens to 2 to 3 minutes. After that, the eruption dies down. But if the interval between two eruptions is greater, 80 minutes, okay, then the eruption seems to go almost 5 minutes. That's what this means, actually. So this is how we are not able to draw a straight line in this case. But by using the clusters together, you can say if the interval between two eruptions is 40 to 60, the duration of the geyser of the eruption is 2 to 3 minutes. Otherwise, it is 4 to 5 minutes. Now, this is an important principle that we need to grasp as far as cluster plots are concerned. Now, other ways to find out relationship. Okay? There are associations. How do you find associations? Okay. Let us say the points are like this, okay, going like that. This means that the association is a negative association. Need to put it straight because they will be watching like this. So do it like this, please. Okay. This is a negative association. If the association goes this way, which we know, this is called a positive association. And if it's all scattered up here and there, it is called no. There's no association. Okay, if it's scattered everywhere. This is an example of no association. Right? Plot the points are, there's no linear association. In here, at least you have a linear association. You see that it's going down, right? As the x-axis increases, the y value is going down. So you can draw a line in such a way that there are equal number of points on the top and equal number of points on the bottom avoided, and you get a linear relationship. Okay. Now, in this case, Susan asked 20 people if they could buy a new product. She developed at each of several prices. The scatter plot shows how many of the 20 said yes at a given price. Describe the association between the price and the number of buyers. So this is the price and this is the number of buyers. What does this mean? It means 2 people said they will buy it at a price of 12. but only one person, okay, but 20 people said they will buy it at a price of $2. So that's what this means, okay. As price increases, see, this is the price. As price increases, what happens to the buyers? The number of buyers decreases. That's what this is. So this is a negative association, right? Describe the association between the price and the number of buyers. Here you see a negative association. It is similar to this plot on the top. Okay, it is similar to this plot on the top, a negative association. Please do problem 6. These are all straightforward problems. Problem 6 on page 397. On page 397. Question 3 on page 398. Question 5 in page 399. 5, 7, and 9, okay, in 399. Now, trend lines and predictions. Trend lines and predictions. This is a 14.2. I've already explained, when you have plots or the points all scattered around, let us say points are all scattered around, you have to draw a trend line. And how do you draw a trend line? That's what they are asking. Now, trend line is a straight line. As I told you before, there should be equal number of points on the bottom and the top, and the trend line should be drawn such that it connects some of the points of the plot, but equal number of points should be there on the top and the bottom. So in this case, this is the trend line of this scatter plot. Okay, let us look at this example. You have to plot the line. You have to plot this. Distance is on the x-axis, time is on the y-axis. I plotted these points on this line, and these are where the lines are. These are where the points fall. Okay, so I tried to plot a line so that there are equal number of points that on top of the line and bottom of the line. Now, if I take this line like that, okay, there is 1, 2 point here. That's top of the. I'm talking about this line. Okay. There are 1, 2 point that is not on the line, and there's 1, 2 point that is not on the 3 points. That's not on the 1, 2, 3 points. So that doesn't work. If I take this line, okay, if I take that line, there is 1 point here, 2 points on the top, 1 point on the bottom. So you need to find out, okay, and that's how this is called the trend line. You need to draw the trend line in such a way that you miss equal number of points on the top and the bottom. So let us say, I'll give you an example. Let us say that you have a plot like this, okay? And you have 1 point here, 1 point here, 1 point here, 1 point here, 1 point here. Okay, this is a scatter plot. You know that these 3 points can be drawn, and there's 1 on the top, 1 on the bottom. This is actually a true trend line. On the other hand, if you have, let us say you have a plot like this, and you have 1 point missing here, 1 point missing here, and only 1 point missing here, then this is not a true trend line. So you have to move the line in such a way that it captures some of the points and it leaves equal number of points on the top and the bottom. Okay, so this is basically, and they give you an example here after drawing. The scatter plot and the trend line shows the relationship between the number. This is the scatter plot. The points alone are called scatter plot. And this is the trend line. Okay, the blue line is the trend line. Between the number of chapters and the total number of pages for several books. Write an equation of the trend line. So you need to write an equation for this trend line. What are they asking? They're basically asking you to do y is equal to mx plus b. Okay. This is the equation of a line. Remember, this line is what? Though it's a trend line on a plot, on a scatter plot, it represents y is equal to mx plus b line. So what should you find first? They are finding the slope first to find m. Okay, Then they try to find out at what point does B is what, at what point does the line hit crosses the y-axis at 0. So they find the mx plus b is equal to 0, and y is equal to 10x because slope is 10. So the equation of the line is y is equal to 10x. We have done this already. I'm not going to explain it once again. All these things have been done, but here you have the equation of the line with the trend line in a scatter plot, and they may ask you in the exam. Okay, same thing here. You need to do this. This is your question to do on page 403, question 6, right? Page 403, question 6. And in this chapter, what you're expected to do is you plot the points, you draw the trend line, and they may ask you the equation of the line, or they may ask you subsequent questions. Page 405, question 7, question 9, question 11, and on page 404, question 1, 2, 3, and 4. It's basically guided practice. Let us look at this question. Angela recorded the price of different weights and several bulk grains. She made a scatter plot of her data. Use the scatter plot for questions 1 through 4. Draw the trend line of the plot. Okay, in here this is the scatter. So if you draw a line like this, let's say always trend line should be straight line. So if you draw, connecting these 2 points, if you draw a line like that, how many points are above and below the line? This is 1, 2, 3, 4 above the line, 1, 2, 3, 1, 2, 3, 4 below the line. So naturally, this would be the trend line. Now, once you get the trend line, what do they say? How do you know whether your trend line is a good fit for the data? Activity 1, it's a good fit for the data because you have equal number left on the bottom and the top of the line. Let us look at activity 1. To draw the trend line, use a straight edge to draw a line that has both the same number of points above and below it. Ignore any outliers. You can ignore any outliers. So if you look at the plot here, you have 1, 2, 3, 1, 2. These can be considered as outliers, and these can also be considered as outliers because they're too far away from the other line. So you have 2 points on the top of the line that are not avoided, 2 points on the bottom of the line that are avoided. So this is the trend line. Okay, write an equation for the trend line similar to what we have already done. This the equation is y is equal to mx plus b. You need to find the slope of this line. At what point does this line cut the y-axis? That will be b, and you need to find that by substituting x value to it. That concludes this chapter. Also, these chapters are pretty straightforward. We have already done plotting, graphing, and also talked about linear equations. These chapters superimpose the equation of the line on scatter plots. The 2 principles in a scatter plot that we need to be careful about is that scatter plot has points that do not fall on a straight line, but you can make a trend line. This is a trend line out of points. You need to avoid the outliers, which are points that are away. Don't consider that, but draw a trend line in such a way that it captures a relationship between x and y. That is it. We will look at the homeworks on on Friday afternoon, or I'll send another video on Friday afternoon. God bless you all.